Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2020, paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're looking at OCR paper 5 from November 2020. Now paper 5 is the non-calculated paper, so let's get busy. Question 1a, work out -1 plus 6. Okay, so when you're adding and subtracting positive and negative numbers, really good idea to use the number line. So if we started on -1 and I want to add 6, I'm going to start here, aren't I? And adding is going in a positive direction, so I go 1, 2, 3, 4, 5, 6 jumps. Going to take me up to +5, isn't it? Okay. Next one, 7 subtract -3. When you've got two signs like this, kind of next to each other, it's a good idea to resolve them into one before you try and do the maths. So taking away a negative number is the same thing as adding a positive one. Or those two negative signs make a positive sign. So 7 take away -3 is the same thing as 7 plus 3, and 7 plus 3 is 10. Okay, and then part B says write down two prime numbers between 10 and 20. Well, prime numbers are numbers that have exactly two factors. So the first prime number is 2, then you've got 3, 5, 7, not 9 because it's got a factor of 3, then 11, 13. Okay, well that's it, isn't it? I've got those two. So just counting up through the prime numbers, it's 11 and 13. Now you could have had 17 as well, or 19. Those two are also prime numbers as well. Not 15 because it divides by 3 and 5. Okay, so any two of those four prime numbers would be the right answer. Question 2, write 350 centimeters in meters. Well, 1 meter is the same thing as 100 centimeters, isn't it? Okay, so if I want to convert centimeters to meters, I need to divide by 100, don't I? Okay, so divided by 100, 350 divided by 100, just move the decimal point 2 jumps to the left. It's going to give me 3.5, isn't it? So that's 3.5 meters. Right, 1.52 liters in milliliters. 1 liter is the same thing as 1,000 milliliters, isn't it? Okay, so to convert from liters to milliliters, we need to multiply by 1,000. Okay, or in other words, shift the decimal point 1, 2, 3 places. 1, 2, 3. It's going to give me, just put an extra 0 in there, it's going to give me 1520. Okay, so 1,520 milliliters. Okay, and then finally work out 5.7 centimeters plus 30 millimeters give your answers in centimeters. So let's convert them both into centimeters first. 1 centimeter is 10 millimeters. Okay, so converting this one here into centimeters first, that's going to be 3 centimeters, isn't it? I have to divide by 10. So I'm going to have 5.7 plus 3. That's going to be 8.7 centimeters, isn't it? That's my answer. 8.7 centimeters. Question 3a. Complete each statement by writing the missing value in the box. 1/3 is the same thing as 2 what? Okay, well, to go from here to here, we are timesing by 2, aren't we? Okay, and if you want an equivalent fraction, whatever you do to the numerator, you have to do to the denominator, and vice versa. So if I times the denominator by 2, I'm going to get 6 there, aren't I? So 1/3 is the same thing as 2/6. Part 2, 1 and 1/7 is how many sevenths? Well, the easiest way to do this is to take these two numbers at the here and multiply them first. So 1 times 7 is 7, and then you kind of add this one on the top here. So that's going to give me 8 sevenths. Part B, work out 0.8 divided by 2. Well, 8 divided by 2 is 4, so 0.8 divided by 2, that's going to be 0.4. And then I've got 1.7 times 2. Well, 17 times 2 would be 34, so 1.7 times 2 is going to be 3.4. Question 4a, write 0.16 as a fraction in its simplest form. Now, after the decimal place, the first digit after that represents tenths, and the second one represents hundredths. So I'm going to rewrite this as a fraction over 100. So 0.16, that's the same thing as 16 100ths. Okay, so that is a fraction, an equivalent fraction to 0.16, but is it in its simplest form? Just need to look for common factors top and bottom, see if we can cancel it down. Now 16 has got factors 1, 2, 4, 8 and 16, and I'm pretty sure I can divide 100 by 4 as well. So if I divide them both by 4, I'm going to get 4 over 25. Okay, 4's got factors 1, 2 and 4, none of which are factors of 25, so that's about as simple as it's going to get then, isn't it? So 4/25 is my final answer. And then part 2, write 7 over 20 as a decimal. Now I'm going to do this as the division. How many times does 20 go into 7? Actually, let's draw it a little bit closer here. Well, it doesn't go, does it? It doesn't go in. It goes in 0 times. And I'm going to have to put a 0 on there, 7.0, so I can carry the 7 over. So how many times does 20 go into 70? It goes in 3 times, isn't it? 3 20s are 60. So it goes in 3 times, and the remainder is 10. So let me add another 0 here and carry that 10 over. Okay, and then 20 into 100, that goes 5 times exactly. Okay, so I get 0.35 as my answer. 0.35. Question 5a, write down the mathematical name of each of these shapes. Now, a triangle with 3 equal sides, that's just an equilateral triangle, isn't it? Equilateral triangle. A quadrilateral with 4 equal sides and no right angles. Well, if it was 4 equal sides and right angles, it would be a square. So I'm guessing if there are no right angles, it's going to be a pushed over square then, isn't it? Which we call a rhombus. Okay, so that's a rhombus. Part B says, here's a rectangle. On the diagram, draw the rectangle's 2 lines of symmetry. Okay, so let's get the old ruler out. So it's going to be like halfway, isn't it? I might measure it so I can get the things in the right place. So on mine I've got 1, 2, 3, 4. This is going to be a slightly different scale to yours, isn't it? That's 4.7, so half of that is going to be 2.3 and a bit. Okay, now my kind of magic ruler is going to be slightly, well, it's not going to work out the same as yours, but if you measure it with a ruler and then half that distance, probably is the best way to draw your line of symmetry, because you want to go down exactly down the middle. And then the same the other way. Now my little magic ruler, I've got kind of 20 divisions, so halfway is going to be there. Okay. So then I can draw my line of symmetry going this way. Okay, and those are my two lines of symmetry. The rectangle has rotational symmetry of order 2. And Maya says a rectangle is the only quadrilateral that has a rotation symmetry of order 2. Is she correct? No, she's not. Because I can think of another one. If I have a parallelogram, that also has a rotational symmetry of order 2, because it looks the same upside down, doesn't it? So I'm going to say no, because parallelograms also have order 2. Okay, so I only need to find one example, because she says it's the only quadrilateral. So as long as if I can find one other example, then her statement isn't true, then, isn't it? Okay, that's all I need to do. Add the correct symbol to the diagram to show that AB is parallel to line DC. Well, this is AB and this is DC. So to show that these two lines are parallel, normally in maths what we do is we put those little chevrons on it. Okay, so like there and there. Okay, now if you had two pairs of parallel lines like this, you could put one chevron on one and two on the other. Now you can put them at the end of the lines or at the middle of the lines, it doesn't really matter, but you have to have like the same number of arrowheads on each pair of parallel lines. Okay, question 6. Clara travels from her home to Stoke. The distance from her home to Stoke is 100 miles. She travels an average speed of 50 miles per hour. She stops for 20 minutes on her journey. Clara arrives in Stoke at 10:10 a.m. At what time did she leave home? Okay, so what we're going to need is the total time for her journey. We know that she stopped for 20 minutes on the journey, but we don't know how long the actual travelling part took. But we do know that it was 100 miles, and we do know that she was travelling at an average speed of 50 miles an hour while she was travelling. Okay, so we can use those two bits of information to find the time the journey took, and we can then add on the 20 minutes, and from that we can work backwards to her time that she left. Okay, so we're going to start by trying to work out that journey time. We're going to use the DST triangle, distance, speed, time. Let's just pull out our values D, S and T from the question. Distance travelled, well, that was 100 kilometers, wasn't it? So sorry, 100 miles. So that's 100 miles. Speed of the journey, that was 50 miles per hour. 50 miles per hour. And the time, well, that's what we're trying to find, isn't it? The time is what we're trying to find. Okay, so what we do with the DST triangle, we cover up the thing we want to find, which is T, and that tells us what to do with the other two. Because the D is above the S, we know then that time equals distance divided by speed. Okay, so then it's just a matter of subbing those values in then. Distance is 100, speed is 50, divide one by the other, we're going to get 2. What's the units? We've got miles divided by miles per hour, so then that's going to be hours. Okay, so the time taken for the actual travelling part is 2 hours, but she also rested for 20 minutes. So it's going to be 2 hours plus 20 minutes, give me a total travel time of 2 hours and 20 minutes. So then if she arrived at Stoke at 10:10, we need to kind of wind back 2 hours and 20 minutes. Okay, so going back 10 minutes would take me to 10 o'clock. Going back another 10 minutes would take me to 9:50, and then taking 2 hours off of that would take me to 7:50. Okay, so 10 subtract our 2 hours and 20 minutes, okay, is going to take me to 7:50. Okay, so that's the time then she set off. So she leaves at 7:50 a.m. Question 7. This is Nadia's bar chart to show the number of goals scored by 4 teams during November. So we've got numbers of goals scored in November. On the left-hand side, we've got the numbers of goals scored. That goes up to 13. And along the bottom, we've got City, United, Rovers and Albion. They're the teams, aren't they? Okay, now Blake says Nadia's bar chart shows that United scored twice as many goals as City. Is Blake correct? Give a reason for your answer. Now, when you have a look at the height of United's bar here, look, then it appears that it's like 1, 2, 3, 4 units up, and City's from here to here, look, looks like it's 1, 2 units up. So on first glance, it does look like United has scored as many goals, or twice as many goals as City. But if you have a look over here, actually what we've got going on is what's called a broken scale. The scale doesn't start at 0, so it's not like 0, 1, 2, 3, 4 going up the scale. It actually starts at 8. So the difference between 10 and 12 is only 2. It's not twice as many, it's just 2 more. Okay, so that the answer is no, and the reason is the chart uses what we call a broken scale, so doesn't start at 0. Okay, you could go on and say, or the other way of saying it was say, well, the different 12 is not double 10. That's another way of arguing it. Okay, either of those is acceptable. Part B, give one way in which Nadia can improve her bar chart. Well, she could improve it by not using a broken scale. She should start her scale at 0. Okay, and then Kareem says, out of these 4 teams, United achieved the highest mean number of goals per game during November. What assumption has Kareem made? Well, mean number of goals is like the total amount of goals achieved or scored divided by the number of matches played. Now, we've only got the number of goals scored here, like the total. We don't actually know how many games each team played. One might have only played 1, and one have played 4. So, just by looking at the chart, we can't know for sure that United has the highest mean number of goals. I think Kareem must have assumed that each team played the same number of matches. Okay, so each team played the same number of matches in my very poorly written handwriting. Question 8a, write 3 times 3 times 3 times 3 is a power of 3. Well, we're multiplying 3 by itself 4 times, aren't we? So that is 3 to the power of 4. Show that the answer 2 to the 6 times 4 to the negative 1 is a square number. Okay, well, maybe we'll have to work out what it is. Now, 4 to the negative 1, when you've got a negative index like this, that means the reciprocal of your number, isn't it? So that's actually 2 to the 6 times by 1 over 4. That's what 4 to the minus 1 means. So a power of negative 1 means 1 over that number. So actually what we've got here is 2 to the 6 divided by 4. Okay, combining those two things together. Now 4, that is actually the same thing as 2 squared, isn't it? So what we've got here is 2 to the power 6 divided by 2 squared. And when you've got two numbers with the same base, then we're going to subtract the indices, aren't we? So that is the same thing as 2 to the power of 6 minus 2, which is 2 to the power of 4. Okay? Now we need to show that this is a square number. Well, we could say that 2 to the power of 4 is the same thing as 2 squared, isn't it? Okay, because when you've got an index and an index like this, it's like multiplying them together. So this is the same thing as 2 squared, and therefore it's a square number. So it's a square. The other way of doing it would just be to work it out, really. So 2 to the power 6 is 2, 4, 8, 16, 32, 64. So 24 is 2 to the 6 the same thing as 64. And if you can divide that by 4, that is going to give me 16, and I know that 16 is 4 squared. So that's another way of doing it. Okay, so if you didn't like doing it with all the powers, you could just do it with the numbers instead. Okay, so that's an alternative way of proving it. Question 9, write each of the following ratios in their simplest form. Now you can cancel ratios down just the same way as you would with fractions. If I gave you 12 over 15, you'd be looking for common factors, top and bottom, that you could cancel it down. Now 12 and 15 have got a common factor of 3, so you could divide top and bottom by 3 and you would get 4/5. Okay, that's how you cancel down a fraction. We're going to do the same thing with the ratio over here. 12 and 15 have got a common factor of 3. So just dividing both sides by 3, it's going to give me 12 divided by 3 is 4, 15 divided by 3 is 5. So 4 to 5 is the most simple version of that ratio. Just take care with the second one, because we've got different units here. We've got grams and kilograms. So the first thing I'm going to do is convert them both into the same unit. So I know that 1 kilogram is the same thing as 1,000 grams. So you have to multiply 1.8 by 1,000 in order to do this ratio. So actually I've got 600 grams to 1,800 grams. So that's the true ratio. I'm going to divide both sides by 100 first to make it a little bit easier. In other words, I'm just going to cross those two zeros off. So that's going to give me 6 to 18. And then I'm going to look for common factors. Divide by 6. Divide by 6. Divide by 6. So that's going to give me 1 to 3 then. And that's my final ratio then, isn't it? 1 to 3. Okay. Question 10. Simplify 5b to the power 6 divided by b squared. Now again, I've got two things with the same base, b and b. So I'm going to subtract the indices. So 5b to the 6 divided by b squared, that's going to be 5b to the 6 take away 2, which is 4. So 5b to the power of 4. Okay, here we've got an index of an index, so we need to multiply these together. X to the 4 raised to the power 3 is x to the 4 times x to the 4 times x to the 4, which is x to the 4 times 3. That's x to the 12. Okay, so just applying your laws of indices that you need to know. Question 11. Theo invests £500 at a rate of 6% per year simple interest. Work out the interest he receives in 1 year. Okay, so I'm going to do this by chunking, I think. So let's start off with 100%. That's equal to £500. So 10% would be a tenth of that. That would be 50. 5% would be half of 10%. That would be 25. And 1% would be a tenth of 10%. So 50 divided by 10, which would be 5. Okay, so if then that he receives 6% interest, he's going to start off with his 100%, and then he's going to add on 6%. So if I add the 5 and the 1 to the 100, that is going to give me 106%. Okay, doing the same thing over here, 525 and 5, that adds up to 530. Okay, so that's my answer from 30. Okay, work out the value of the investment after 5 years. Well, altogether he's getting 25 plus 5, that's £30 interest per year. Now in simple interest you just get the same amount of interest each year, so the total then after 5 years is going to be his initial investment 500 plus 5 years worth of £30. Okay, so 5 lots of 30, well that is 150. So multiplying first gives me 150, and then add into the 500, that's going to give me a total of £650. Okay, so the value of the investment after 5 years is going to be 650. Question 12. A jacket has its price reduced by 20% in the sale. The sale price is £56. Work out the price of the jacket before the sale. Okay, so I'm going to use a fairly similar method to the last question here. I'm going to kind of chunk it. But let's just be clear. If the original cost of the jacket was 100% and we reduce it by 20%, then the sale price represents 80% of the original value. So it's 80% and not 100% that is equivalent to 56. Now, if I want to work out the price of the jacket before the sale, what I want to do is kind of work out what 100% of the cost of the jacket is. Okay, so how am I going to do that? Well, if I can work out what 10% is, say, and then I could add on 2 10s to the 80, and that would make 100, wouldn't it? Okay, so if 80% is 56, then what is 10%? Well, you can see that 10 goes into 80 8 times. If I divide 80 by 8, I'm going to get 10. So if I divide 56 by 8, I'm going to get 7. So 10% of the value is 7. Now we want 100%, so we can make 100% by taking one of our 80s and two of our 10%. So 80 and 10 together make 100. So doing the same thing this side, we'll take one of the 56s and we'll take two of the 7s, add them together, and that should give us 100% then, shouldn't it? So 2 7s are 14, add on to the 56, that's 66, 70 altogether. So 70 is the final, or is the original price of the jacket before the 20% was taken off. Okay, so we call that a reverse percentage. It's a little bit trickier than just finding the percentage of a number. You just need to think it through carefully. Question 13. A bag only contains red, blue, yellow and white counters. A counter is taken at random from the bag. The table shows the probability that it's a red and the probability that it's a blue. Now we're told here that there are twice as many yellow counters as white counters in the bag, and I need to complete the table. Okay, right, we're going to have to do this with a bit of algebra because we don't know how many white counters there are, X, so I'm going to call it X, but I do know that there are twice as many yellow counters as white counters, so I could call that one 2 lots of X or just 2X. Okay, and I know that probabilities all added together by completion, these things should add up to 1, shouldn't they? Okay, so each of these probabilities added up is everything, it's certainty, and that is equal to 1 in terms of probability. So if I take these values, 0.24 plus 0.34 plus the 2x plus the x, I'm certain to get one of those 4 results, so that must add up to 1 in terms of probability. Okay, so let's then combine these two together. What's 0.24 plus 0.34? That's going to give me 0.58, and I've got 2x and x, so collecting like terms together there, I'm going to get 3x. Okay, so I've got 0.58 plus 3x is equal to 1. So I need to find x, don't I? So I need to make x a subject, or solve for x basically. So let's take away 0.58 from both sides first. So that's obviously going to cancel with that, and it's going to leave me with my 3x on this side. Okay, on the other side, 1 take away 0.58. be 0.42. Okay, so 0.42 added on to 0.58 gives me 1. So 3x equals 0.42. And then dividing both sides by 3 is going to give me x. 0.42 divided by 3. Well, 42 divided by 3, what would that be? 42 divided by 3 is into 42 would be 14. So 0.42 divided by 3 is going to be 0.14. So that is what x is. So that means x over here is 0.14. And then double that for 2x is going to be 0.28. Okay? So they're my two results. 0.14 and 0.28. Question 14a part 1. Sketch the graph of x equals 3. Show clearly any values of any intercepts. Well, I know that one straight away. Any graph of the form x is equal to something is going to be a vertical line parallel to the y-axis. Okay, and it's going to pass through the x-axis at 3. So that point there is 3. Okay, so that's it. That is the graph x equals 3. Part 2 says sketch the graph of y equals x squared plus 1. Show clearly any values of any intercepts. Okay, so I know that y equals x squared looks like that. So if I then add 1 to it, it's going to shift it 1 unit up. It's going to look like that. Okay, so it would have passed through the origin. Now it's going to pass through 1 above it. It's going to pass through 1 at that point there. Okay, so I'm going to draw my parabola with the minimum point on the y-axis, and that value there is the point 1. Part B says Toby has sketched the graph of y equals 1 over x below. Make 2 comments about the accuracy of his sketch. Okay, well, first things first, he has got the curve touching the axes. Now, if you draw y equals 1 over x, what you should get is a curve that looks like this. Now, the lines approach the axes, but they never actually touch. So he's got his curve touching the axes when they should only get closer and closer but never touch. Okay, so one of my comments about it is that the graph touches the x-axis and y-axis, which is not correct. Okay, so there's one thing he's done wrong. So the graph touches the x and the y-axis, and it shouldn't. The other thing is that he's only drawn half the graph. There's another part of the graph that goes down here. Okay, there's a kind of like a mirror image of it down here. Look, in the negative quadrant down there. So the other comment is going to be he missed the other part of the graph for negative values. Question 15a, simplify 4a minus 2b minus 2a plus 5b. So this is just a matter of collecting like terms, isn't it? So 4a is alike to the minus 2a, and the minus 2b is alike to the 5b. Okay, so let's collect those together. So 4a take away 2a, well that's 2a, and negative 2b plus 5b. If I'm at negative 2 on the number line and I want to add on 5, I'm going to go negative 2, negative 1, negative 0, 0, 1, 2, 3. It's going to take me up to 3, isn't it? So negative 2b plus 5b is the same thing as positive 3b. Okay, so 2a plus 3b. Multiply out 4 lots of x plus 3. 4 lots of x is 4x. Don't forget to multiply the last number by 4 as well. 4 lots of 3, that is 12. So I get 4x plus 12 is my final answer. And finally, x plus 5, x minus 2 multiplied out and simplified. Now, there are different ways of doing this. You could use FOIL, first, outside, inside, last, or 2 eyebrows, a nose, and a mouth. But if you struggle with this, I do recommend doing it as a grid method. So x plus 5 in that direction and x minus 2 in this direction, and then you can use the grid to help you work out the answer. So x times x is x squared, x times positive 5 is 5x, x times minus 2 is minus 2x, and minus 2 times 5 is minus 10. Okay, so you've got 3 types of terms here. You've got a term in x squared, that goes at the beginning, so x squared. And then we've got 2 terms in x. I've got 5x minus 2x. Now we need to combine these together. So 5x take away 2x, that is the same thing as 3x. And then finally I've got minus 10 on the end, minus 10. Okay, so like I say, if you do struggle with multiplying out double brackets like this, I do recommend doing it as a grid like this. It's a great way of making sure you don't miss one of the terms out. Question 16, the diagram shows a square. It doesn't look like it. I've got like 4x minus 10 here, and I've got 11 minus 2x. So the two sides are the same because it's a square, but they're expressed differently. Okay, by setting up and solving an equation, show that the perimeter of the square is numerically equal to the area of the square. Okay, so we need to work out what x is basically. Now it's a square, so all the sides are the same, which means this side is equal to this side, it's equal to this side, it's equal to this side. And that means if all the sides are equal, then it must mean that 4x minus 10, the left-hand side there, look, is equal to the 11 minus 2x side. They must be identical, even if they look different. Okay, so if they're the same, I can say 4x minus 10 is equal to 11 minus 2x, and now I can solve for x, can't I? Okay, I've got unknowns on both sides, so I'm going to collect the x's together first. So add in 2x to both sides. That's going to cancel with that one. And it's going to leave me with 4x plus 2x on the left. So that's going to give me 6x minus 10 is equal to 11. Okay, now the next thing I'm going to do is I'm going to add 10 to both sides. Okay, that will get rid of that one. Leave me with 6x on the left, and then 11 plus 10, well that's 21 on the right. And then finally to get x by itself, I'm going to divide both sides by 6 then, isn't it? That will cancel with that, leaving me with x. 21 divided by 6, 6, 12, 18, it goes in 3 times remainder 3, so 3 and 3, 6, which is the same thing as 3.5, isn't it, or 3.5. So x is 3.5. So what does that make the lengths of the sides of this this square then? So the square side then, so side of square then, that's going to be 4 lots of 3.5, the value of x, minus 10 then, isn't it? Okay, so 4 times 3.5, 3.5 doubled and doubled again basically, 3.5, 7, 14. 14 take away 10, that's 4. Okay, so it's a square of side 4. So then the perimeter is going to be 4 lots of 4, isn't it? Which is equal to 16. And the area is also going to be 4 times 4, which is equal to 16. Okay, so yeah, there we go. I can just say same. Okay, so I've shown that numerically the perimeter and the area is both equal to 16. Dora has the following number card. She's got a 2, 2, 3, 5 and a 6. She takes a card at random, replaces the card and then takes a second card. Okay, so this is independent probability. She replaces it. There's an important consideration there. So for every selection, first and second, she's got the same possibility of picking all 5 of those cards. Okay, right, so when she picks them out, she's taken a note of the number, she's added the numbers together and recorded the results in the table here. Okay, so we need to complete the table. So you can see that every cell inside the table is the sum of the two, the row and the column that it's in. Okay, so the gaps here then, like 2 plus 5, that is going to be 7 there. 3 and 3 makes 6. And 5 and 2 makes 7. Okay, so we're done. That's all complete. Part B says find the probability that her total is an even number. Well, how many even numbers are there? There are 5 times 5 altogether. Remember, probability is equal to successful outcomes over total outcomes. Okay. So how many outcomes are there altogether? I've got a grid with 5 times 5 spaces in it. So that gives me a total of 25 different possible outcomes. So we need to know how many of those outcomes are even. So we can just go through and count. Okay, I'm just going to go through and I'm going to highlight all the ones that are even. That one, 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 and that one. Have I got them all? That looks good. So how many is that then? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the probability of getting an even number is going to be 13 out of 25. Part 2 says a multiple of 3 or 4. Okay, so I'm going to go, because I've already highlighted last time, I'm just going to ring the numbers this time. So I'm going to ring the multiples of 3 or 4. So 4 is a multiple of 4, 4 is a multiple of 4, 5 and 7 aren't, 8 is a multiple of 4. Those are multiples of 4, that's a multiple of 4. That's a multiple of 3. That's a multiple of 3. That's a multiple of 4. That is a multiple of 4. That's a multiple of 4, and so is that, and so is that's a 3, and that's a 3 and a 4. Okay, is that all of them? 11's nope, 7's nope, 5 nope. That's all there is. So how many of those are there? There are 3, 6, 9, 10, 11, 12, 13, 14 of those. So there are 14 out of 25. Okay, it's 14 out of 25. Question 5. Charlie and Jasmine share cartons of apple juice. Charlie drinks 1/3 of a carton every day. Jasmine drinks 2/5 of a carton every day. Any apple juice left in the carton at the end of the day is used the following day. The cost of a carton is 70p. Charlie and Jasmine buy just enough cartons to last them for 10 days. How much do they spend in total for these cartons? Give your answer in pounds. Show your working. Okay. Well, I suppose what we need to do first is to work out how much they drink between them, because I've got 1/3 and 2/3 there, don't I? Okay, so if I find what that fraction is together, so what's 1/3 plus 2/5? Need to find a common denominator, don't we? So what's the common denominator out of 3 and 5? I think that's 15. 3 times 5 is 15. There's nothing smaller that 3 and 5 go into. So let's convert them both into 15ths. Now 3 goes into 15 5 times, and 5 goes into 15 3 times. So that's going to give me 5 15ths and 6 15ths, and that altogether is 11 15ths. Okay, so they're drinking 11 15ths of a carton every day. Okay, now how many days are we doing this for? We're doing this for 10 days. Okay, so how many cartons is that altogether? So total is going to be 11 15ths multiplied by 10, then, isn't it? Okay. How are we going to do that? I suppose we could do 110 over 15. 110 over 15. 15's into 110. I quite like leaving things as top-heavy fractions, but I want to know how many cartons we've got altogether now, so I need to cancel it down. And also, it's needs simplifying anyway. Now, both these numbers divide by 5, so I'm just going to double it, 220, and then divide by 10. 220, 22. So that's 22 over 3 then. Okay, dividing by 5, top and bottom is 22 over 3. So 3's into 22 goes 7 times. So that's 7 1/3 cartons of juice that they need. Okay, now they need enough to last them 10 days. So they're going to have to buy 8 cartons then, aren't they? Because if they buy 7, they don't have enough, and you cannot buy 1/3 of a carton. So we're gonna purchase 8 cartons. So we require 8 cartons then, don't we? Okay, 7 is not enough. 8 is a bit too much, but at least they've got a bit left over for the next day. Okay, so how much does 8 cost? The cost then is going to be 70 pence times 8. 8 sevens are 56 plus a 0, so that's £5.60 then, isn't it? Okay, as in pounds and pence, £5.60. Okay, give your answer in pounds, £5.60. Cool, that's it. Question 6. A clock chimes every 20 minutes. A light flashes every 8 minutes. The clock chimes and the light flashes together at 8 o'clock. How many times between 8 and 12:30 will the clock chime and the light flash together? Show your working. Okay, now this is actually like a lowest common multiple question if you think about it. Let's take the clock first off. So it chimes at 8. Okay, and then 20 minutes after that. So how many times is that going to chime between 8 and 12:30? I think I'm just going to list them out until I get a feel for it, because I actually don't think it's going to be that many. So that's 3 times an hour then, isn't it? So then 9, 20, 9, 40, 10, 10, 20, 10, 40, 11, 11, 20, 11, 40, 12, I run out of space, and then it's 12:20 as well, isn't it? 12:20. Okay, so obviously this one at the top doesn't count because we're counting it at 8:01, so that one is too early. So how many times it chime? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now, what about the light? The light flashes every 8 minutes. Now, I'm going to start off writing these down. I probably won't do the whole thing because that's quite a lot I'm going to have to write down, and I'm a bit lazy. So it does it at 8. So the next one is going to be 8:08. I might just do an hour because then it's going to be will it be the same? Well, let's see. 8:16. Then it's going to be 8:24. Then 8:32, then at 8:40, okay, then at 8:48, then at 8:56, then no, it won't chime on the hour. It'll go to 9:04 then, won't it? And then 9:12, 9:20. Okay, so where's it chiming together then? So 8:40 I noticed there, look. So it chimes at that one. And then the next time it chimes will be at 9:20 then, won't it? Okay. So notice it's chiming every 40 minutes apart, isn't it? And that isn't surprising because 8 and 20 both have 40 as their LCM. So the LCM of 8 and 20, that's going to be 40, isn't it? It's every 40 minutes it's going to be chiming together. Okay, so every 40 minutes after that then it's going to be chiming here, 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 here. Okay, so how many times is that? It's 1, 2, 3, 4, 5, 6. It's going to chime 6 times. 6 times together. Question 7. A pattern is made from 4 congruent right-angled triangles. The line AC is parallel to the x-axis. The point A has coordinates 4, 9, and the point B has coordinates 17, 12. Work out the coordinates of point C and point D. Okay, so we know that all 4 of these triangles are congruent, so they share the same lengths and things, don't they? So we should be able to work out what those lengths are. I think we're going to have to work those out so we can work out the various coordinates. Now, what information do we know? We know this point over there, B. So we know that this down here has got to be 17, isn't it? Okay. And this value down here is 4. Okay, so the distance between there and there is 13, isn't it? Okay, so the distance between here 4 and up to 17, that is the distance of 13. Okay, and that is the same thing as 2 of the shorter sides of my triangle and 1 of the longer sides. Okay, so if we called, let's say we call the short side, what should we call it? Not Fred, let's call it like X and Y for now. So if I draw a right angled triangle where let's call the long side X and the short side Y. Okay, then what do we know? We know that 2 of the shorter sides and 1 of the longer sides, X plus 2Y, that is going to be equal to 13 then, isn't it? Okay, I'm going to do a similar thing on the other side. So if you have a think about over here, this length here then is going to be, that's 12, isn't it, from the coordinate of that top point, and this one is 9. So the distance between here and here is 3. Okay, and that is the same thing as one of my lengths here. Okay, so then that means that my short side then is 3. Okay, so then I can work out what the long side is then. So if the short side is 3, so then working out the long side, X plus 2 lots of Y, X plus 2 lots of 3, that's equal to 13. So then X is going to be 13 take away 6, that's 7. So X is 7. Okay, so basically the longer side of one of these triangles is 7 and the shorter side is 3. So then that's 3, 3, 7, 7 from there to there then, isn't it? Okay, so 3, 3, 7 and 7, that takes me 3, 6, 13, 20. That's 20 units along. Now the X coordinate from the point A is 4. Look, this one over here is 4. So the X coordinate for this point over here is going to be 20 plus 4. It's going to be 24. Okay, now it's the same height as the point A, so that's going to be 24, 9. Okay, and my point B, oh, we already know. What about my point D? My point D is going to have 6 units along from the point A, which takes me from 4 up to 10, and it's going to be 7 down then, isn't it? It's going to be 7 units down from A. So this is a y coordinate of 9, so this one must have a y coordinate of 2. Subtracting 7 from 9, I'm going to get 2. Okay, so the coordinates from C then are 24, 9, and the coordinates of D are 10, 2. Question 21, solve the simultaneous equations 2x plus 3y is 10 and 3x plus 5y is 17. Okay. So we're going to solve these by elimination. We're going to try and get the same number of x's or y's in both equations, and then take one away from the other to leave us just one unknown. And then we're going to subtract one from the other to just leave us with one unknown. Okay, so I'm going to start off, I'm going to call this equation 1, and I'm going to call this one equation 2. Okay, now in order to make them the same, I'm going to multiply this one by, well, it depends. We could either get rid of the x's, in which case we could multiply this one by 3 and this one by 2. I might do that actually. So let's multiply. Let's get rid of the x's. So if I multiply it by 2x by 3, I'm going to get 6x. If I multiply 3x by 2, I'm going to get 6x. And then I can eliminate them that way, can't I? Okay, so taking the first equation and multiplying it by 3, that's going to give me 3 lots of 2x, that's 6x. 3 lots of 3y, that is 9y. And that's going to be equal to 3 lots of 10, which is equal to 30. So we're taking each of the 3 terms of this equation and scaling it up by a factor of 3. Okay, so that's my first one. Now my second one, I'm going to get 2 lots of 3x, that's going to give me 6x, plus 2 lots of 5y, that's going to give me 10y, and then I'm going to get 2 lots of 17, so that is 34. Now I'm going to take one away from the other to cancel. I'm actually going to take the top one away from the bottom one because I want to keep y positive. If I did it the other way around, so I'm going to take the top one away from the bottom one. Okay, so 6x take away 6x, they're going to cancel each other out, aren't they, and disappear. 10y take away 9y leaves me with y, and 34 take away 30 leaves me with 4. So that means that y must be equal to 4. Okay, if I'd taken 10y away from 9y, I'd end up with negative numbers, so I didn't want to do that. Okay, so now I've got y is equal to 4. I can substitute that back into one of my original equations. So substitute y equals 4 into equation, which one? Either one, doesn't really matter. I'm going to put them into equation 1. Okay, so I'm going to sub it into equation 1. So that means that my 2x plus my 3 lots of y. Well, I know that y is now equal to 4. So my 2x plus my 3 lots of 4, that is equal to 10. So multiplying out that bracket, that's going to give me 2x is equal to 12. 2x plus 12 is equal to 10. And then subtracting 12 from both sides. Okay, that's going to cancel. Leave me with 2x. So 2x is going to be 10 take away 12. That's negative 2. And then dividing both sides by 2. That's going to leave me with x equals negative 1. Okay. So x is negative 1. It's a good idea just to test this or check it. You can check it by subbing both values into the other equation. So I used equation 1, so I'm going to sub in y equals 4, x is 1 minus 1 into the second equation. 3x plus 5y is equal to 17. Just to check it's going to give me the same value. So 3 lots of negative 1 plus 5 lots of 4, is that equal to 17? Okay, well 3 lots of negative 1 is minus 3, 5 lots of 4 is 20. That's true, isn't it? Because minus 3 plus 20 is 17, and I've got 17 on the other side. Okay, so this little check, useful to do in the exam. It's just a good way of double checking that you've got the answer right. Okay, now this was worth quite a lot of marks. How many was it worth? 4 marks. So it's a good idea to try and get it right in the exam rather than find out afterwards you've got it right or wrong. A weather forecast says the probability that it will rain on Monday is 0.55 and the probability that it will rain on Tuesday is 0.25. Ella draws a tree diagram to show this information. I've got the diagram here and I need to write down 3 errors that Ella has made with her tree diagram. Okay, so let's go through this step by step. The probability that it will rain on Monday is 0.55. Okay, so Monday 0.55, that looks correct. So the probability of something not happening is 1 minus the probability that it happens. So the probability that it does not rain shouldn't be 0.35 here, should it? It should be 1 minus 0.55, which is 0.45. Okay, so she's got the probability of not raining incorrect. So prob for not raining on Monday should be 0.45, not 0.35. Okay, so she's written 0.35, it should be 0.45. Okay, so that's our first error. Let's have a look at the rest of the diagram now. The probability that it rains on Tuesday is 0.25. So the probability that it will rain on Tuesday, well, she's got that the wrong way around, hasn't she? She's written it here, so she's got that the wrong way around. So she's written the probability of it not raining as 0.25. So that's my second. On Tuesday, she has reversed probabilities for raining, which should be 0.25 and not raining. Okay, so they should be the other way round. What else? I think the final error that she's done, she's omitted this part of the diagram down here, isn't it? So she hasn't taken into account the probability that it may not rain on Monday but rain on Tuesday. So omitted part of diagram for not rain on Monday, not rain on Tuesday. So this part of the diagram should be 0.25 for rain and 0.75 for not rain. Okay, so that should be on the diagram there. Question 23. AOB is a sector of a circle centre O. The area of the sector is 8 centimeters squared. Work out the exact value of the radius, which is r centimeters. Okay, so we want to know what the exact value of this radius is. Now, we can see the angle in the centre of this sector, which is 120. That means this sector is 120 360ths of a full circle, isn't it? Because there are 360 degrees in a full turn, 120 degrees at the center of this sector, so that gives me 120 360ths. Now 120 actually goes into 360, doesn't it? It goes in 3 times, so I can divide top and bottom by 120, which shows me that this is actually 1/3 of a circle, isn't it? Okay, so the area of a sector, do you know the formula for area of sector? It is the angle at the center over 360 times pi r squared, which is the area of a circle formula, isn't it? Okay, now in this case we had 120 over 360 times pi r squared. Now r is what we want to find, isn't it? Okay, and we know the area of the sector is 8. Okay, so I can sub that in on that side. We already worked out the 120 over 360. That simplifies to 1/3. So 1/3 lots of pi r squared. Okay, so we need to try and get r by itself. Okay, now we can do that by times in both sides by 3 to start with. That's going to cancel with that, leaving me with 8 16 24 is equal to pi r squared. Okay, now dividing both sides by pi. Now I don't have a calculator, so there's not really much more I can do other than kind of move it to the other side of the equation. So I'm going to get 24 over pi is equal to r squared. Kind of running out of space a bit here. Let me just move up a bit. So 24 over pi is equal to r squared. Now to get r by itself then, we're going to need to take roots of both sides, aren't we? Because the square root of r squared is going to give me r. So that's going to leave me r on the right side there. And that's equal to 24 over pi, all rooted. Okay, that's all I can do really. I can't evaluate it more than that without a calculator, but we wanted the exact value. That's the exact value as best as I can work out without a calculator. So r equals 24 over pi, all square rooted. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.